Good afternoon, class. Here's exam for review. Chapter 4, Applications of Differentiation. Chapter 5, Integrals or Anti-Differentiation. 6.1 Areas between the two curves. And in this part, we're going to cover 4.9 Antiderivatives and 5.1 Areas and Distances. First, in order to do anti-differentiation, which is the reverse process, you got to be very comfortable with differentiation. For example, we know the derivative of kx, where k is a number, is a constant, is k. Therefore, the integral of the right side must be kx. Of course, we put a dx next to it. Dx tells us what is the independent variable. And it has a constant because in the case of an anti-differentiation, there are infinitely many solutions. You get a family of solutions because c has a derivative equal to 0. The power rule, the derivative of x to the power of n is nx to the power of n minus 1. So what is the integral of x to the power of n? The reverse process gives us 1 over n plus 1, x to the power of n plus 1, and it can't be negative 1. I'm going to look at this from 2 points of view. First, I'm going to show you the process. Then we will prove that in the beginning of learning division, remember, we would multiply to check the work. So the same thing, you can differentiate the right side to check your work. It has to give you x sub n. As far as the process, if you look at x to the power of n, everybody, when you want to differentiate x to the power of n, the process is that you multiply it by n and you subtract 1 from the exponent n. Now, for integration, we do the reverse process in that order. Instead of subtraction, we're going to add 1 to n. And then instead of multiplication, we're going to divide by n plus 1. And that gives rise to this answer. However, if you take the derivative of this side, let me rewrite it in this format. Let's even write the plus c. So the derivative is 1 over n plus 1 times the exponent n plus 1, x to the power of n plus 1 minus 1, plus the derivative of c, which is 0. And I hope you see that this gives you x to the power of n. Okay, that's it. So that's a proof. Reverse process. Let me erase the mess. Now we know the derivative of e to the power of x is e to the power of x. Therefore, the integral of e to the power of x dx must be e to the power of x. The derivative of ln x is 1 over x. The integral of 1 over x must be ln x plus a constant, by the way. All of them have a constant. The derivative of sine is cosine. The integral of cosine must be sine. The derivative of cosine is negative sine. So the integral of sine is negative cosine. All of them have a constant, everybody. Tangent. The derivative of tangent is secant squared. So the integral of secant squared, and we have to put dx. That tells us what is the independent variable. That is tan x plus a constant. The derivative of cotangent is minus cosecant squared. The integral of cosecant squared dx is minus this negative. We take it to the other side. Minus cotangent of x plus a constant. Secant gives you secant x tan x. So the integral of secant x tan x is secant x, and of course a constant. And the derivative of cosecant is minus cosecant cotangent. The integral of cosecant cotangent dx is minus cosecant x plus a constant. Just as an example, when we differentiate it, if we had a coefficient, it would remain as a coefficient. The same thing works out with the integration. Sum and difference, we just do them as sum and difference. We do differentiation term by term. We do integration term by term. The Derivative of e to the power of kx, we multiply it by k, and we write the same thing. The integral, we are going to go with the reverse process. We're going to divide by k. And if you differentiate that, you'll see that you get e to the power of kx. So those are some of the formulas, and we are going to look at examples to make some sense out of it. So finding the all functions g such that g prime is 4 sine x plus 2x to the power of 5 minus square root of x over x. What is the solution? So let's discuss the solution. Sometimes you will need to simplify first. Factor, cancel, remove radical notations, etc. Sometimes you will need to integrate using substitution. This is coming up. Therefore, we are going to make up two fractions here, this one and this one. Algebraic techniques gives us the following answer because this is x to the power of 1/2. And class, this one doesn't have an exponent. The exponent is 1. 1/2 minus 1 gives you negative 1/2. So we are going to find g of x by integrating the right side times dx. Remember, g prime means dg dx, so you have to have a dx, otherwise you can't integrate. So let's do it one by one. Sine, the derivative is cosine, the integral is negative cosine. So minus 4 cosine x minus 4 cosine x plus 2x to the power of 4. 2 divided by 5x to the power of 5 because you're adding 1 to 4. So I'm using the power rule on that. This one as well as this one, I'm going to use the power rule. And remember, sine, the integral is negative. So this one, you're going to say minus, and according to this formula, 1 over n plus 1. So 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. This is positive 1/2. 1 over that makes it 2. So minus 2 x to the power of 1/2 or minus 2 square root of x. And of course, plus a constant, we are done. So let's look at a few examples. We are going to integrate term by term, all of which are going to use the power. So this one would be 2 divided by 4 plus 1. 2 divided by 5, x to the power of 5. 3 divided by 4, x to the power of 4. Minus 7. 2 plus 1 makes it 3. Minus 7 thirds, x cubed. X gives you half of x squared. Why is that? And you don't write the exponent is 1. So 1 over 1 plus 1, x to the power of 1 plus 1 makes it half of x squared. Minus 5, x plus a constant. Very straightforward, everybody. If we wanted to differentiate this, we would do the same thing, algebraic step first, and we would write it as x squared minus 10x plus 25 times dx. I'm assuming nobody has any problem with that. Step by step, term by term, we would differentiate, we would integrate, and this will give us 1/3 x cubed, right? Because you add 1 to the exponent and you divide by. Now minus 10 divided by, remember, this one, the exponent is 1, you add 1 to it, minus 10 over 2, or minus 5x squared. So let me quickly show you. So for this one, you would say minus 10 divided by 1 plus 1 over times x to the power 1 plus 1, because the exponent for x is 1, plus 25x and a constant. We are done. And again, remember, the answer is a family of functions. The answer is not unique. The answer, we have infinitely many solutions. That's why this is also known as indefinite integral. Indefinite integral. Again, if we were to differentiate, we would do the same thing and we cut it into three pieces. X squared divided by x squared is 1, minus 7x over x squared is minus 7 over x, plus 2 over x squared. So we cut it into three fractions. Now, to integrate each part, we want to write it in a manner that it becomes clear. Remember, the integral of 1 over x dx is ln x plus 1. So if you have it in a slightly different format, you want to recognize that, by the way, 1 over x is the same as x to the power minus 1. So we're going to write this as minus 7 times 1 over x because we want to recognize this. And this one, we're going to write it as 2x to the power of negative 2. So 1 gives you x. Minus 7 over x gives you minus 7 times 1 over x. Therefore, minus 7 ln x. By the way, the reason we put this in an absolute value because y equals ln x has a domain of 0 to infinity. To be on the safe side, we use an absolute value. Now, the last part, 2x to the power of negative 2. For this one, we're going to say 2 over negative 2 plus 1. X to the power of negative 2 plus 1, which makes it minus 2 x to the power of minus 1. So minus 2 over x plus a constant. Pay attention to the fact that we have dt, therefore the integral of 1 is not x, it's t. Cosine, the derivative is negative sign, but the integral is positive sign. So plus sine t and a constant. To differentiate or integrate makes no difference. First, we have to change this, x to the power of 1/3. Now we can use the power rule on that. 1 over 1/3 plus 1, x to the power of 1/3 plus 1. Minus, the derivative of sine is positive cosine, but the integral of sine is negative cosine. So minus negative cosine x plus a constant. You might say, well, I know that if it's negative sign, then it becomes positive cosine. I'll change it to positive. That's absolutely fine. So we were using this one on this last one. Now, of course, 1/3 and 1, they add up to 4/3. 1 over 4/3 is 3/4. So x to the power of 4/3. And x to the power of 4/3, you can write it as a cube root of x to the power of. What do we do here? Again, even if we were differentiating, we would change this to x to the power of 1/2. We divide this one by this one, this one by this one, making up two fractions. I hope you recognize the exponent is 1 here. So 1 minus 1/2 makes it 1/2. So the first one is x to the power of 1/2. The second one to the power of negative 1/2. Everything that you see so far, it's just basic elementary algebra. So I hope everybody is fine with that. Now we are going to integrate, and we can use the power rule. So for this one, 1/1/2 plus 1, x to the power of 1/2 plus 1. For this one. For this one, 1/-1/2 plus 1, x to the power of -1/2 plus 1. And of course, we have a constant, everybody. Now, I want to emphasize this class. This is the only calculus step we have done a bunch of algebraic steps, and now we're going to continue with algebra. So 1/2 and 1 is 3/2. 1/3/2 is 2/3. 1/1/2 is 2. You can keep it as that. If you want to change it to a radical format, you can. This one is square root of x. This is x square root of x in case. We want to integrate this first. This one is two fractions, 1 and 2 over x squared. So that's the first thing we want to do. Now, one by one, we are going to integrate. Therefore, 1 gives you x. 2 over x squared, we change it to 2x to the power minus 2, and now we are going to differentiate this one, which means 2 over -2 plus 1, x to the power of -2 plus 1, which means 2 over -1 or -2, x to the power of -1. So minus 2 over x, minus 2 over x. Finally, secant squared. You know the derivative of tangent is secant squared. Therefore, the integral of secant squared must be tan x, and of course a constant. And now we are done. Solve the initial value problem. dp dt is 2e to the power of 3t, p of 0 is 1. So the question is, what is an initial value problem? Any equation containing a derivative is called a differential equation, or DE. A function which satisfies the equation is called solution to the differential equation. An initial value problem is a differential equation along with a specified value of the unknown function called the initial condition. So if you forget about the initial condition and this, which is a pair 0, 1, we have been dealing with the differential equation. So we are going to ignore it for a moment. I'm going to put the dt to the other side, and we're going to integrate both sides. And the left side becomes p of t. We are going to divide by 3. So we get 2/3 e to the power of 3t plus c. Now, if we didn't have this condition, we would be done. But that condition means the following pair, 0, 1. So if you replace the t with 0 and p of t with 1, as you know, this is e to the power of 0, which is 1. So you have 2/3 plus some number is 1, which makes it 1/3. And this is going to replace that. This is the answer. So what did we find? This is a general solution class. And that's exactly what we have been doing. This is a particular solution. I want to make sure I want everybody to understand the concept. Over here, we have an indefinite integral. We have a family of functions. We have infinitely many solutions. When one pair is given, it will help us find the value of C. From a general solution, we go to one solution, which is known as a particular solution. Depending on the pair, we can find that. A different pair can result in a different answer. However, when x or t is 0, that is called initial value problem. Here's another one we want to solve. Again, we're going to ignore the pair 1, 5. Please understand this is the pair. And dy is the right side times dx. If you integrate both sides, the left side becomes 1. Y, my apologies. We are going to change square root of x to x to the power of 1/2 and bring it up. So the first part is very straightforward, is simply 1 over x, and it results in ln x, ln of absolute value of x. The second part uses the power rule. So 1 over -1/2 plus 1, x to the power of -1/2 plus 1, and a constant. Of course, minus 1/2 and 1, 1/2. 1 over that is 2. So we have 2x to the power of 1/2, or 2 square root of x. You see, so what you have is a general solution. Let's plug in the pair 1, 5, meaning replace the x with 1, y with 5. As you know, this is 0, this is 1. So 2 plus what number is 5? Number 3, replace it, and this is a particular solution. Okay. All right, so the concept of an initial value problem, to recap that, is the same as before. We solve it with a constant, and then we use the pair to get rid of the constant. It becomes an initial value problem. So the fact of the matter is, when one pair is given, you can find the missing C. A particle moves in a straight line and has acceleration given by a of t 6t plus 4. Its initial velocity v of 0 is -6 centimeters per second, and its initial displacement s of 0 is 9 centimeters. Find its position function s of t. First, what is a rectilinear motion? For motion in a straight line with constant acceleration, a, initial velocity v sub 0 and initial displacement s sub 0. The displacement after time t is s of t equals half of a t squared plus v0 t plus s sub 0. It can be proved easily. Okay. In fact, you can give it a shot on your own, and you're more than welcome to come and ask me how it's done. When we go through this, it should make it easy. For now, we know, therefore, that v prime is a of t. S prime. Let me just write this. V prime is A of t. S prime is V of t. Okay. By the way, this is equal to also S double prime. So V prime is A of t, or 60 plus 4. Therefore, if I want to get to V, I have to go with the reverse process and integrate that. By now you have done it. So if you want to, antiderivative of this is 3t squared plus 4t plus a constant. That's V of t. However, because we are given this pair, this is infinitely many solutions. Because of this pair, we can find the constant to be -6. So V of 0 is the same as C. V of 0 is negative. If you plug in 0, everybody, gives you C. You see that? On the one hand. On the other hand, V of 0 is -6. So that is your value for C. Replace it, and that becomes the velocity function. You have to go one more step to find S of t. S is the antiderivative of this. T cubed plus 2 squared minus 6t. I'm not going to use plus c. I'm going to use something else. I'm going to use plus d on purpose because I don't want anybody. You can use c, but I don't want anybody to think it has to be the same number. Therefore, I use a different value. Now, if I plug in 0, becomes d. So S of 0 is 9. D is 9. Plug in. Again, if you plug in 0, you get D. On the other hand, S of 0 is 9. And so here's S of t. All right. A sample of cesium-137 with an initial mass of 79 milligram decays T years later at a rate of -1.8249 e to the power of -0.0231 T milligrams per year. Find the mass of the sample after 23 years, and we want to go with 1 decimal. So first, let M of T represent the mass because M, therefore M of T. That's what they do in science and physics. If you said Y of T is fine. If you said F of T is fine. Okay. M representing mass. So what is given? We want to understand the problem. So we want to write the given. Given dm dt is this. That means the m dt is -1.8249 e to the power of -0.0231 t. Initial mass, that means at t equals 0, m of 0 is 79. That will help us find m of t and then replace the t with 23 to find m of 2. That's what we are going to do. So to do so, you put the dt here and you integrate, and this becomes m of t, and this becomes the integral of the same thing with the dt, everybody. Okay. According to this, you're gonna divide by k. So you are going to divide this number by -0.0231, and then you add a constant, right? And you write the same thing. When you put it into a calculator, this creates 79. We know m of 0 is 79, right? We're going to use that, which means we are going to replace the t with 0 and m of t with 79. E to the power of 0 is 1. So 79 plus C, obviously C becomes 0. And that is your M of T in general. Now, M of 23, replace the T with 23. 79 e to the power of negative 0.0231 times 23. You multiply these two, you raise e to that power, you multiply it by 79, you put it into a calculator. How many decimals? 1. So this is the one that you need. To the right of it, it's important to do the rounding properly. It doesn't mean you just put the 4 and forget. Look at this one. This doesn't change, but if it was, let's say, to 2 decimals, then this would change to 4 because it's 9. So be very careful with your rounding. Areas and distances, section 5.1. So here's the synopsis of what's coming up. Suppose a continuous function f is defined on the interval of a to b if the interval is divided into n subintervals so that delta x is b minus a over n, and x of 0 is a, x of 1 is a plus delta x of 2 is a plus 2 delta x, and all the way. A Riemann sum associated with f is the sum of f of x sub I delta x as I goes from 1 to n, which means f of x of 1 times delta x plus f of x of 2 all the way to f of x of n times delta x. X sub I is any point in the interval of a sub I minus 1 and a sub I. So geometrically, what it means, class, we have we are dealing with a function, and we have an interval of a to b. If we cut it into n pieces, let's pick up a number, for example, 4 subintervals. Then we make 4 rectangles. The width is delta x b minus a over n, and we change it to 4. The heights are f of x of 1, f of x of 2, f of x of 3, f of x of 1. And if we make it into 8 or more rectangles, we are fine with that too. As the number of rectangles increase, the approximation gets better. The concept is as follows, everybody. If you happen to have a curve and you want to find the area under the curve from A to B, so you cut it into so many pieces. For example, if I cut it into 4 pieces and keep this as delta x, and we're going to keep it fixed as delta x b minus a over n, okay? Because it makes it easier to calculate. What you have, it looks almost like a rectangle. So how do you find the area of a rectangle? The width times the height. So what is the height? Is it this one? Is it this one? Is it somewhere in between? Any point in between will do the job. But to be consistent, you use the left endpoints, right endpoints, midpoints, whatever. It becomes an approximation, not there. What is interesting, if you cut it into more pieces, for example, from 4 we go to 8, then it becomes closer to the actual area under the curve. And if you let n go to infinity, it becomes the actual area. So that's the concept here. So let me erase this and continue with that thoughts. We want to look at the following: the left endpoints, the right endpoints, the midpoints. Here's the formulas, and what I do when we look at an example, I'll show you an easy way rather than memorizing this. So if you're using the left endpoints, you're using them for the functional value to represent the height. The width is fixed at delta x. So that stops before, so it goes all the way to before we get to b. for the left endpoints. For the right endpoints, all the points except A. For the midpoints, the points in between. Again, I will quickly show you. And so this is the approximation for 4 subintervals. A is summation of I equals 1 to 4 of f of x of I delta x. And here's what we have: f of x of 1 delta x, f of x of 2 delta x, all the way to the fourth one. However, as the approximation gets better and as n gets larger, approximation gets better. When n goes to infinity, becomes identical to the area under the curve. And what do we mean by that? Let's go over a simple example to make some sense out of what we just said. We want to use the left endpoints, right endpoints, and midpoints rule with n equals 5 to approximate this. So first, and these are the formulas, and this is general formula, but I'm going to show you how easy you can find it without really paying attention too much to the formula. You need to know what is your function. Your function is 1 over x. A is 1, B is 2. Delta x, B minus A over n. 2 minus 1 over 5. So first, this is the graph of f of x equals 1 over x. So this one is the graph of f of x equals 1 over x. A is 1, the lower limit, B is the upper limit 2. And this is the area we want. Delta x is b minus a over n, or 1 over 5. N is given, okay, everybody. And it's 0.2. Now, the idea is that to come up with, this is the interval, come up with 5 lines, okay? It means 4 in between, okay? So we have 5 equal parts. Because this is small, I'm going to make this larger. 1 to 5, 1 to 2, this point, this distance, everybody, is A to B. I just made it larger so it becomes easy to see. So it's going to go from A equals 1 to B equals 2. Because delta x is 0.2, let's add 0.2, 1.2, 1.4, 1.6, 1.8, and so on. So if you follow this, it's a very easy process, okay? So delta x times those, delta x times those, delta x times those are ln, rn, mn. This is the left endpoints, right endpoints, midpoints. So in short, when you want to use the left endpoints, this is used, all of them are used except B. So for the left endpoints, everybody, you don't use this point, okay? So you are going to write delta x, which is 1 over 5, f of x of 0, x of 1, x of 2. So f of this point, f of A, then f of this point, f of 1.2, f of 1.4, f of 1.6, f of 1.8. Each one represents the height. Each one must be multiplied by the width, which is delta x. So if this is f of x, what is f of 1, 1 over 1? What is f of 1.2, 1 over 1.2, and so forth. So I hope you can see that. So one more time. Delta x is this one, 1 over 5 or 0.2. F evaluated at all of those 5 points except the last one. Why is that? Because we want the left endpoints. You're going to put it into a calculator and you put it with a bunch of decimals. So this part, just put it into calculus. Now for the right endpoints, let me clean this part. For the right endpoints, you are not going to use A. So you're going to write exactly the same thing, 1 over 5 times, okay, f of 1.2, 1.4, f of 1 plus f of 1.4 plus f of 1.6, and so forth. So 1 over 1.2 plus 1 over 1.4 all the way to the last. And again, use a calculator to come up with the answer. What I want you to notice is this. This part is the same as this part. And so the endpoint for the left endpoints, the first one, A, this is f of A. For this one is f of B. But everything else is the same. So one calculation will help you. So that makes the calculation nice and easy. However, for the midpoint is a different story. The last one is the midpoint. What are we going to use? Let me use a different color. What color? Okay, this one. So for the midpoint, you start from this point. This is the middle of the first subinterval. So this would be 1.1. Then this one. So, which is clearly 1.3, or just add 0.2 to 1.1 and continue. So M5, and by the way, M stands for the midpoint, 5 it stands for the choice of N. Notice what we have now. This you have to calculate. It doesn't help you that you have those. F of 1.1, F of 1.3, F all the way to the end. Now what is F of 1.1? 1 over 1.1, 1.3, 1 over 1.3, and the rest of them. So this is pretty tedious, but very straightforward. And here's the answer. Midpoint is between the two numbers, and it's a better approximation than both of them. So again, to recap, when you want to calculate the area, when you want to approximate the area under the curve, you use this line segment from A to B. You blow it up so you can see all the numbers easily. If it's large here, you can use it right here. If not, just make it up here. And you go from A to B, cut it to N pieces, whatever N might be. And then you just ignore the first one for the, that means A for the right endpoints. Ignore the last one for the left endpoints. For the midpoints, just find those points. All right. Can somebody read this question, please?
I can read it. The velocity of a moving object is given by the function v of x equals 3x, where x is in hours and v is in miles per hour. Use geometry to find the area under the graph. Which is the distance the object has traveled? A. During the first 3 hours.
Perfect. That means x must be between 0 and 3. If v of x equals 3x, as you know, that means a line that goes through the origin. So graphing it shouldn't be a big deal. And because we are dealing with time for now, we are going to go on the positive side. Okay. Time travel is not yet possible. It will be in the future. I guarantee you that. And so what's happening here, we know that distance in this case is the area under the velocity function. We want it between 0 and 3. That's why we have 0 to 3 along the x-axis. Area of this is half of base times the height. So we need to know the base. This point has coordinates 3, and 3 times 3, 9. Therefore, this is not to scale, by the way. This is 3, everybody, and this is 9. So maybe I write it like this. So this distance is 3, this distance is 9. So 27 halves, or 13.5 miles. So again, distance is area under the curve of the velocity function. What about between the 3rd and the 5th hour? So we do the drawing. We have two choices to calculate this area. We can calculate the area of this triangle and this rectangle and add them up, or we notice this is a trapezoid. The formula is half of a height times b1 plus b2. The height is 2. Look at this one. The height is 2. This is b1. This is b2. b1 equals 9. b2 equals 6 plus 9, 15. So you plug in 24 miles. 24 miles. Use the definition to find an expression for the area under the graph of f as a limit. Do not evaluate the limit. We will discuss evaluation later on. F of x is given as x squared plus the square root of 1 plus 2x, and x is between 4 and 7. Find delta x and x sub I. The area under the curve is exactly equal to this limit, the limit of f of x sub I delta x, as I goes from 1 to n, and as n goes to infinity, delta x is b minus a over n, x sub I is a plus I delta x is b minus a over n. We will look at the proper way of finding it. And so according to this, therefore, a is 4, b is 7, delta x is b minus a over n. So a is 4, b is 7, delta x is b minus a, meaning 7 minus 4, meaning 3 over n. So that's delta x. What is x sub I? A plus I delta x. A is 4 plus I times 3 over n. So A is 4, this one times I. So that's where you have it. This is, I'm showing you how to do the calculation with details. So here's the Riemann sum, and the area is precisely this limit. The limit of summation of f of x sub I delta x as I goes from down to n is approaching infinity. So we found x sub I, and we have f of x. We are going to evaluate f of x sub I. That's exactly what they're asking us to do, everybody. We want to find f of x sub I. So with that being the case, all you have to do, replace this x with 4 plus 3i over n. Same thing for this x. That's all you have to do. That's f of x sub I. Let's go back to the question. We want to use the definition to find an expression for the area. We want this one, everybody. We want this one. So what do we have? We have this part. So we are going to write the limit of sum as n goes to infinity, summation of I equals 1 to n. F of x sub I, we replace it with f of x sub I. Delta x, we replace it with delta x, 3 over n. 3 over n. Okay, everybody. Again, it's very straightforward. Of course, this can be evaluated. We're going to discuss that later on, but for now, we just want to set this up. Determine a region whose area is equal to the given limit. Do not evaluate the limit. It's important to know that it doesn't have to be unique, everybody. So let's see how we deal with that. Well, let's write the limit. Same thing as we did in the previous page. We need to calculate delta x. Delta x is given. And f of x sub I is given. So delta x, let me just do this. Delta x is this part. F of x sub I is this part. When you put them next to each other and compare it. Okay, let's do that one more time. I want to make sure we understand that. Compare these two. This must be delta x, and this must be f of x sub I, right? Compare the two next to each other. Delta x is b minus a over n and equals 3 over n. X sub I is a plus I delta x. We know delta x is 3 over n. From here, one approach would be that a plus I delta x. If you compare these two, delta x is 3 over n, a is 1. Compare. Right? So if a is 1, if a is 1 and b minus a is 3, b must be 4. If a is 1 and b minus a is 3, b must be 4. So we have the function y equals the square root of f of x, and in the interval of 1 to 4, a to b. And by the way, whenever you're done, if you have any doubts, just go through the process of getting back to this. So represent this in this format. Remember what we did in the previous page? See if you can get it. Now, what's interesting It is not unique. You can make some changes. For example, delta x, we know it to be 3 over n. So if we say x sub I, which is a plus I delta x, a plus I delta x, if we claim it to be 0 plus I delta x, so a becomes 0, b becomes 3, a becomes 0, and b becomes 3. Then what happens to the function? Becomes 1 plus x. What about the a and b? 0, 3. So you can check that these two are identical. F of x squared of x and the interval of 1 to 4, or is 1 square root of 1 plus x and the interval of 0 to 3. You can look at this with more details later on to see that that would be the case. Now, here's the last question we want to do. Could somebody read that, please?
I can read it.
Please.
The velocity graph of a car accelerating from rest to a speed of 120 kilometers per hour over a period of 30 seconds is shown. Estimate the distance traveled during the period. Use M6 to get the most precise estimate. Round your answer to 2 decimal places.
Excellent. Thanks. This is the velocity function. This is the area under the curve, which represents the distance. Area under the curve represents the distance. So how do you find this area? Well, since they said m sub 6, that means n is 6. So first, let's calculate delta x, which is b minus a over n. And now we're going to call it delta t, because this is not x, this is t. Delta t is 30 minus 0 divided by 6, 5 seconds. So every 5 seconds, everybody. Every 5 seconds. So this is 5, 15, 25. What I want to show you quickly, show you the concept of a left endpoints, right endpoints, and then the midpoint. So let me clean up. So if you go with 5 and 15 and 25 here, so this, okay, so this is 1, 2, 3, 4, 5. So please understand, there are 6 sub-intervals, all of which have the same delta x, in this case delta t, 5 seconds. So the width is constant. It makes it easy. Now, if I want to calculate the area for each one, I can approximate it. How? If I use the left endpoints, f of this point, if this, the first one doesn't create any area, f of this point, f of this point, f of this point, those are the height, okay? Now I can find, for example, this height as f of 5, this height as f of 10, this height as f of 15, this height as f of 20, this height as f of 25. And I don't use this one because I'm talking about the left endpoints. I don't use the last one. That's a rough estimate of the area under the curve and the distance. If I want to use the right endpoints, so I would use this one. This would be the area. Okay. This would be the area. 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 So this one. All the way to the last one, right? Now, and none of them, the left endpoints or the right endpoints, create the area under the curve for me. But it gives me, I mean exactly, it gives me an approximation. But if I want to use the midpoints, let me clean up the mess. Okay, it makes life easier. Now, before we do that, I want you to notice the units, kilometers per hour, seconds. So we're going to change the seconds to hours. You know, 1 hour 60 minutes, 1 minute is 60 seconds, so 1 hour is 3600 seconds. So delta t is 5 seconds divided by 3600, or 1 over 720 hours. So delta t with the proper units is 1 over 720 rather than 5. So let's locate those. And the way we locate it, again, I told you one easy way is just a line segment going from 0 to 30 and cut them into pieces. 5, 10, 15, 20, 25, and so forth. So I want the midpoints here and here and here and here and here. So I want these points class along the x-axis. Okay. And those points, okay, using the formula, of course, m sub n is delta x times f of x1 bar plus f of x2 bar and so forth. Now, in this case, would be what? First of all, the velocity at 2.5, right? Because this is 2.5, everybody, right? In the middle, I can write it either, let's see, either here I would write it as 2.5, or here I would write it as 2.5. And then you add the delta t, okay, 5, so this is 7.5. And then add 5 all the way to the end. So this is what you get for this part. And delta x is delta t now, which is 1 over 720. Why 1 over 720? We discussed the unit conversion. So what do we need to do? We need to write this distance as the height for the first one, this distance as the height for the second one, this distance, so we're looking at this distance as the height for the next one, this one for the next one, this one for the next one, this one for the last one. So this one as an example, roughly, again, this is a rough estimate. Okay, this is 80, this is 40, this is 20, so this is a little bit more than 30, 31.25. You don't have to be exact, but you get the answer. For this one, about 66, so on and so forth. You do your best to read the height or the second coordinate or the y coordinate for those points. Add up those points, multiplied by 1 over 720, you get 0.725 kilometers. So over the course of 30 seconds, according to this, it covers 0.725 kilometers. And Everybody knows that 1 mile is about 1.61 kilometers.